Welcome to today's lesson on dividing integers by fractions. Today we're going to learn how to use a number line as well as a formula to be able to divide integers by fractions. Let's go ahead and get started. Let's begin today by doing a word problem. Sarah had 5 oranges for her basketball team. If each teammate received half of an orange, how many teammates were there in all? Well, we know we're starting with 5 oranges and we're dividing each of these oranges in half. So how many teammates will that be? Let's start using a number line with the pictures below. So to do so, let's set up our number line. We're going to start our number line with 0, and we have 1 orange, so I'm going to label 1. Our second orange will be labeled 2, 3, 4, and 5. So we now have our number line labeled. But we need to divide these 5 oranges in half. So now I'm going to label half for each of our holes. So I'm cutting this orange in half and labeling half on my number line. Half, 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 and half. So I've now split up each of my holes into halves. And now I can add up how many teammates there were in all if each teammate received half of an orange. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means that there are 10 halves in all. So 5 divided by half equals 10. Well, guess what? You could have looked at this problem a different way as well. You could have looked at it as multiplication, which is the inverse or opposite of division. So you also could have said that you knew that 2 halves equal 1 whole. So if you have 2 halves in a whole and you multiply that by 5 oranges, that would equal 10 teammates. So 5 times 2 equals 10. Well, when you're dividing fractions, you actually can do the inverse and multiply. Let me show you how that works. We have 5 divided by half equals 10. We do the inverse operation of division, which is multiplication, and we can say that 5 times 2 wholes, notice we flipped our 1 half over into 2 wholes, equals 10 wholes. And 5 is the same as 5 wholes. 5 times 2 equals 10, 1 times 1 equals 1, and we know that 10 over 1 is equal to 10 wholes. So when you're dividing by fractions, you can actually do the inverse operation and flip your fraction over to equal your answer. Let's try another example together. Let's say I want to divide 3 divided by 2 eighths. Well, all I have to do is find the inverse of division, which is multiplication. So I'm going to say 3 times. But if I'm going to do the opposite operation, I need to flip my fraction. So now I'm multiplying by 8 halves. Now it's also helpful to turn your whole number into a fraction just by putting a 1 beneath it, and then you can multiply. 3 times 8 equals 24. 1 times 2 equals 2. And then you can go further and you can simplify your answer. You're going to divide your numerator and your denominator by the greatest common factor that they both share. In this case, we're going to divide our numerator and our denominator by 2. 24 divided by 2 equals 12. 2 divided by 2 equals 1. And that gives us 12 wholes. So 3 divided by 2 eighths is equal to 12 wholes. Let's go through some practice problems together. Can you divide 9 divided by 1 half? Well, remember, we're going to start by doing the inverse operation. So we're going to multiply 9 times 2 over 1. Now I'm going to turn my 9 into a fraction, 9 wholes, and multiply across. 9 times 2 equals 18. 1 times 1 equals 1. And I can't simplify this any further, so 9 divided by half equals 18 wholes. Let's try another problem together. 4 divided by 3/9. All right, let's start by setting up the inverse operation. We're going to be multiplying 4 wholes times 9/3. Because remember, we had to flip these around since we changed our operation. 4 times 9 equals 36. 1 times 3 equals 3. But we can go one step further and simplify this if we divide our numerator and our denominator by 3. 3 divided by 3 equals 1. 36 divided by 3 equals 12. So 4 divided by 3/9 is equal to 12 wholes. Let's practice a word problem together. Marissa is dividing up her 6 boxes of colored pencils. Each person in her group will receive 2/3 a box of pencils. How many people are in Marissa's group? Well, let's start by using a number line. I'm going to label my number line 1, 2, 3, 4, 5, 6. Now we know that we're going to be dividing our number line into thirds. So I'm going to divide each of my sections into thirds. And then we can go ahead and group 2/3 together at a time. So I've now split my number line into thirds. Now I need to group 2/3 at a time. So I have 2/3, 2/3, 2/3, 2/3, 2/3, 2/3, 2/3, 2/3, and 2/3. All right, so now I have 1, 2, 3, 4, 5, 6, 7, 8, 9 whole groups. Now let's go ahead and check our work using the formula. We had 6 boxes that we divided into groups of 2/3 each. So let's start by doing the inverse operation. 6 times 3/2. And I'm going to make this 6 wholes. There we go. 6 times 3 equals 18. 1 times 2 equals 2. And we can go one step further and simplify this by dividing our numerator and our denominator by 2. 18 divided by 2 equals 9. 2 divided by 2 equals 1. So this also gave us 9 wholes. That means that there are 9 people in Marissa's group. Let's review what you've learned in today's lesson. We're going to start by reviewing our number line. When you're dividing by fractions, you can write out a number line using your whole number first and then dividing it by the fraction. So I'm going to divide each of my wholes in half. Then I'm going to circle how many halves I have. I have 1, 2, 3, 4 in all. You can also complete the inverse operation. So we have 2 divided by 1/2. When we write it as an inverse operation, we say it's 2 wholes times, and then we flip over our half so that we have 2 wholes. 2 times 2 equals 4, and 1 times 1 equals 1, which is also equal to 4 wholes.